Hello. In one of those videos that I've uploaded yesterday, or was the day before yesterday? I don't seem to remember the dates nowadays. Uh, I've uploaded the video about the browser, but in that I forgot to mention about the internals of the Sherlock browser modules. So this video basically addresses that problem. Okay, so I'm going to explain exactly how the browser module works, and we would be looking at Sherlock browser.py and Sherlock model.py. So let me start off with Sherlock browser.py. Okay, here it is. So we download the OS, sys, regular expression, time, and URL lib, Sherlock util, date and time, Sherlock model, and time modules. And we do not have pagination. This is something that we need to add. Um, so that's why I've put it to do here. So pagination is very important because as and when the amount of data increases in Sherlock, um, it would be very hard for you to scroll up and down vertically, and you have to increase the number of scrollable lines um, in the console settings. So that may not be possible always, because if the data is just too much for a single screen to fit, you would obviously be losing a lot of you would be losing some data, and that data might be relevant to you as well. So um, to address that problem, we need to have pagination. Okay, so like press one to the next page, press two to the next page, and go back, go forward, that kind of a thing. Okay, in Sherlock browser, we instantiate model object, and we get the project directories. What we do is, it's all project based. The browsing happens for a given project, so a particular project. So we get the name of the project, and then we descend into the project and look for various artifacts of the project. For example, project nodes, sites that comprise the project, and sessions for the call sites, and so on and so forth. So um, that's how the browsing works, right? You look for one particular um, web page, and then you go through that web page, back and forth, and top to bottom, and left to right, and you basically research that particular web page. So once that web page is done, you go to another web page and you do the same thing again, so that this knowledge gathering happens on a page by page basis. So it is similar to the Sherlock project browsing is similar to that kind of browsing, internet browsing. So um, what we do is, we get the list of projects. Let me open the Sherlock model. I hope it comes side by side. Okay, now let's Control V. Let me open the Sherlock browser here. Here it is. So on the left side you have Sherlock model. On the right side you have Sherlock browser. So as you can see, I'm getting the projects, from the Sherlock model. So let's go to get projects. It's a very simple method. It basically returns the list of projects that Sherlock has so far. So it's in the form of a dictionary, and what we do is we basically look through the dictionary and ask the user, what project that he is interested in. So once we get the project ID, the project IDs and the project names are displayed in the page. So it's easy for the user to uh, give the project IDs as the one that he's interested in to learn more of the project. Okay, fine. So we gather the project input, project choice, and then we check whether it's a digit, and it's part of the project dictionary that we have got so far. And then if it is correct, then we asked for the next set of questions in another menu. So this menu is basically project specific, and I'm sorry, this menu is applicable to all the projects. It's not specific to one particular project. We do not have types of projects. We just have one single project, and it has the same set of data, the same set of attributes and methods. Like for example, crawl sites, sessions of project, and things like that. So we have project nodes, sites that comprise this project, sessions of the crawl sites, tags and labels of this for this project, return to projects menu, return to the main menu, and that's it. Now, if I remember correctly, there is a problem in this module, and the problem is that if you press any key, once the results are shown, if you press any key, you are actually being taken back to the main menu. So this is something of an interesting problem that you should be looking to solve rather. So there is a bug in this code, and that bug is a very deliberate bug. So you should be able to find that bug and fix it. Okay. Um, okay. So here we check if the choice is one, the selected choice is one, the option given is one. We get all the project nodes associated with this project, and there is a method for that in the show nodes for project. On the right side, I'm sorry, on the left side, you can see this method. We are basically getting all the nodes associated with this project. Okay, and then we show the projects, um, and then we show the nodes one by one. Okay, um, node number is the node ID. Node ID in the MongoDB, and date added, when was it added, and then um, so this, if you see a little bit closer, the ljust 5 is basically left justification. Okay, it is left justified with five spaces. Okay, you can have rjust as well. This is one of the methods to make sure your data is nicely formatted and aligned with the rest of the page. Okay, and then we change the date added. The date added in the MongoDB is epoch time. Okay, epoch time from January 1. I mean, if you must be aware of epoch time. It is like 1st January 1970. That is when we start taking the time. We have been taking the time, so that is called epoch. Okay, that particular time date and timestamp is called epoch, January 1, 1970. And since then we have been taking milliseconds um, since epoch. Okay, so it will run. It's a big number. It's a huge number, and it's a float value. So we take the date. We check. I'm sorry. We convert the date. We typecast it to a float value, and then we give it to the local time, and then we reformat it, and yada yada yada. This is something that you should be clearly understanding. Okay. The same thing goes for sites of the project. How many sites are there in this project, and basically getting the list of all those sites. This is where it is. Get sites of the project. Okay, the method in Sherlock model. So again, it's a pretty straightforward one. You basically go to the projects and then go to the crawl sites. And the reason why we need to have the projects collection also is we need to get the name of the project. In the crawl sites, what we have is ID, not the name of the project. So we do a join, manual join, and then we try to get the project name. Okay. Um, so again, that was just pretty straightforward. Uh, choice 2 is okay. Choice 3. For this, we get the sessions of the project. The sessions of the project are okay. So what exactly is a session? Session is a run, a crawl of a given website associated with the project. There could be several runs, several crawls, but run and crawl are one and the same. Okay. there could be several crawls for that particular website in a given day. It all depends on how often Sherlock Checker is running. Sherlockchecker.py is running. So Sherlockchecker.py is invoked by the operating system cron job. Okay, it is something that you have to do it manually, and depending upon how often you want to run, how often you want to get the data from the websites, you have to put a cron job accordingly. Now, as of now, we are not. As of now, we are not. Um, we do not have cron jobs for each and every project. In fact, each and every site in a project. Okay, because a given project will have several sites. Some sites are updated um, immediately, and they're most dynamic in their nature. The content changes often. Some other sites may not get updated. For example, the Twitter of a given person, the Twitter profile of a given person has a scope of changing multiple times in a day, right? Because he is, he's going ahead and um, he's an addict of Twitter, and he's been at it, and he's been giving uh, um, updates of himself and his life on the Twitter every minute or so. But his LinkedIn profile doesn't change. Okay, it doesn't change often, and usually, if he acquires a new skill or changes the job, or works on a new projects, only then that LinkedIn profile changes. So obviously, it makes sense for you to have a cron job run on a particular website. Okay, and from website to website, this cron job will be different. Okay, on some websites we run often, on some we do not. So that functionality is not there. It's a nice to have, because when I was doing this, I got this idea that you might want to do this in future. Okay, so but for now, what we are doing is a session is something uh, which is a run of a crawl of a given website. Okay, that is a session. We can have multiple sessions for the website in a given day, or you can just have one session per day per website. Okay, and in this session, you basically download the entire website, and then you check for you get the content, you get the tag names, you can get all that, all sorts of information from the website. So we display the sessions as well. Okay, we for a given project, we display the sessions, like how many sessions um, have been created so far, and this actually differs from website to website for the same project. Maybe while you're looking for this session information, uh, a crawl for the website might actually be under progress. So but for some other website in the same project, the crawl would have been completed. So uh, for that website for which the crawl has been completed, you would say that okay, two sessions are available. For other websites, okay, you might say that okay, only one session is available. So that kind of mismatch is bound to happen, because it all depends on how uh, when do you check for this, when do you run the Sherlock main program. Okay, fortunately, if you do not run it while a crawl is taking place, then you won't get any um, uh, confused, you won't get any results, by seeing which you will be confused. Okay, so okay, so I guess we are done with the sessions of the project. So basically, these are just simple, straightforward data. I mean, there is no um, mumbo jumbo going on here. It's a very simple thing. You basically call the um, database method for that particular object of Sherlock, and then we get all the list or the dictionary, and then we loop through that dictionary or list, and then we present the data to the user. I mean, there is no rocket science involved here. Okay, it's a very simple database application. Okay. Choice 4 is the tags and labels of the project. I told you already, tags are automatically driven through NLTK, and the labels are assigned by the user. Okay, so let's go to the tags and labels for the project. The method for that is here. Okay. Okay, this is where we basically get that information, tags and labels for the project. Okay, we show that information here, and then the same thing, it's again, it's the same old database related method, and rest of the things like press any key to clear the screen. I mean, press any key to go back to the main menu or go back to the projects menu. There is a bug. I told you earlier there is a bug in which it is not actually going to the projects menu. If I press something, it is going back to the main menu. Okay, you need to find that and fix it. Okay, I guess that 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 concludes the backend introduction for Sherlock browser. So let's go ahead and I'm sorry. Okay, so that basically concludes the. I was actually reading a mail from a friend of mine. Okay, so basically that concludes the um, video for the backend of Sherlock browser. So I'll see you in the next video. Bye for now.